2020 so far has shown me two things. The public perception of normality can shift much quicker than I thought possible just a year ago. And secondly, my trust in the fabric of civilization has certainly not been heightened recently as well. Once again, I come to the same conclusion. The best way to invest in an uncertain future, besides staying healthy, is to invest in your own skills. In my eyes, there is no better security than having basic, timeless skills and being useful to your common man. In that sense, I will put myself to the test once again by taking a trip to the scrapyards on the hunt for quality tools and equipment of times gone by and see if I can pass the test of bringing them back to life. So let's see then what we will find there today. It seems like a local company has thrown out a range of enormously powerful welding machines here. I put one of my shoes next to one of the units so that you get an idea of their size. My love for both welders and heavy machinery wants me to buy all three. But reason wins this time, I guess, as the cost of transportation would probably outweigh their usefulness to me. I will have to think about it though. But what do we have here? An old Shear that I will definitely keep. And at the same spot someone has dumped a whole assortment of old tools, like this old hand drill here. And here is a pretty cool ratchet type hand drill and another weird old ratchet. This is a draw knife, and we also have a rusty scythe and a tiny vise. I will take almost all of these tools with me today. Down here in the dirt, a powerful alarm bell, probably from around the 50s or 60s. This is a keeper. This small enclosure here is from around that same time, and I'll buy that as well. And what is this? A road roller, probably also from around that time period. Next to it, an old machine built by KHD, now simply called Deutz. Both immensely awesome stuff, but again, too heavy and a nightmare to haul away. Here we have an old PlayStation though, I'll keep that one. And in this tub here, a pretty big pipe cutter. I will buy that as well. So let's head back to the workshop then and see that we get these things back to work. I always like to start with something rather simple, say the bunch of old tools we found, and we will then later in the video progress to something more demanding and complicated. But let's take a closer look at all those rusty hand tools and take them apart then. And let's see if we can get them all back to life in one fell swoop. We start with that tiny vise. In order to get the screw out there, we have to punch out this little pin first, and in that manner we're able to get those jaws apart. I try to clean this part a little bit with steel wool so you can see that it was brazed at one point. But we can take a much closer look at this once the rust is gone. This tool is some kind of old ratchet. After spraying some WD-40 on there, the old drill bit can be punched out, and we can see that it has a pyramid-shaped back end, which drill bits used to have back in the day, as you might have seen in earlier episodes. Upon removing the spring, we can see the actual ratchet mechanism. It consists of a gear and a small moving part called a pawl. That's P-A-W-L. In German, the proper word for the gear is Sperrrad, meaning blocking wheel. And the pawl is referred to as Sperrklinge, which means blocking blade. The beautiful name for a ratchet mechanism is Drehgesperre, meaning as much as rotation blocking device or thing. See how wonderfully descriptive the German language is? The next item is called a draw knife, and is a kind of wood planer that can either be used for a rough wood planing job or for removing bark, for example. And here's the next Drehgesperre already. It's an old-fashioned type of hand drill that also has an adjustable ratchet mechanism that can normally switch between left or right blocking or set to neutral, but it's stuck. Upon taking apart that old 4-jaw chuck, we can clearly see that it is a quality tool in the production of which a lot of machining work was necessary. And on the handle we can find the name of the manufacturer, Flott, which is a big name here in Germany. My bench grinder was made by Flott, for example, and there's virtually no metalworking shop here that doesn't at least have one Flott tool of some kind. This time there are a lot of parts to disassemble, and we're literally drenching this thing in WD-40. There are 2 pins that we will have to punch out for that. We also take out the jaws and some of the parts of the ratchet, but only to a point that I deem sufficient to remove the rust and clean everything. You don't necessarily want to remove more pins than necessary, because sometimes they just sit perfectly and you might not get them back in just like that. The 2 pawls will be left in place, for example. I also found these 3 drill bits here that will probably fit into the hand drill. They again have a truncated pyramid at the end of their shafts. And then there also was this other hand drill. Unfortunately, a lot of the parts are missing, and I will probably not restore it entirely. But I'll still remove the old bolt that was added as a handle by someone, as well as the old chuck, already a more or less modern 3-jaw chuck, and we will try to remove the rust from all these parts as well. In order to remove that rust, we will use a combination of chemical and physical methods this time. We had a lot of rather small, complex parts. That's why I will prefer a bath in concentrated citric acid this time. But when you want to remove rust chemically, it is key to properly degrease the parts first, or otherwise the acid will be unable to react with the rust in many spots. The bigger parts are virtually cooked in this large enameled pot here, containing water with some detergent. The smaller parts are put into the ultrasonic cleaner containing that same fluid. The ultrasonic cleaner also heats up the water to around 80 degrees Celsius, which is key. Ultrasonic cleaning is rarely a complete solution, by the way. It is often necessary to use the cleaner, then brush the parts and rinse them off, and then repeat that process. I often have to do this 5 times or more to really get the parts to a point where I consider them clean enough. Now the parts are put into the citric acid bath. When doing this, you need protective gloves and glasses. The citric acid can be bought in solid form as a powder and needs to be dissolved in the water. I'll leave the parts in here for almost 2 days, again with intermediate brushing and rinsing. Now, what rust remains can easily be wiped off with a towel. After drying the parts, they are still a little dull, so I apply some WD-40 and then I start to carefully brush off everything with steel wool. I also use a paper towel to wipe them off and use some sanding blocks here and there. With that being done, we can now start to put the tools back together. We start with that vise. The jaws are put back together and the screw is inserted and screwed in. With larger vices I usually apply grease, but it's really hardly necessary here. In order for the screw to stay inside, I insert a new split pin instead of the old pin that was already deformed beyond repair. So what happened here is that this crank here is probably original, and so are the 2 jaws. This is one piece made from cast, and this is also cast. But then this is just a steel tube that was cut open. And then someone welded the steel tube to this self-made clamp here. And then they brazed this cast jaw to the steel tube. And here the tiny brazed vise meets the bigger vise that I did a bigger brazing job on in another episode. To be more precise, that was in episode 14, while this is episode 17 of this series. In case you want to see more, you can find all those episodes down in the video description. And now we can also put that ratchet back together. The citric acid treatment removed all the rust, but it leaves the tools in this grayish state, which I personally prefer over sanding a historic tool to a point where it is as shiny as a new knife or some part from stainless steel. I think it's okay that a historic tool looks mature. With the draw knife, I do a little more sanding, and then also carefully rework that old edge with a file. Next I add some wooden handles to it, and it's ready to be used again. And now we can put back together what I would call the most beautiful find of this episode, the old ratchet hand drill. It's kind of crazy how much machining would have went into the chuck alone. It has various diameters on the outside, was bored hollow, then also has a square hole inside, a thread on the outside, then slits were cut and holes drilled into it. The pins are reinserted, and now let me demonstrate that ratchet mechanism. And here's what the old drill bits look like now. The manufacturers are Irwin Tools USA, Heller and Schlagring, a German brand meaning brass knuckles. And by the way, I send my best regards to the people at Irwin Tools and to the state of Maine, more specifically the town of Galore, Maine, where it seems they are situated now. I'm always happy to see tools that made it here all the way from the US, and I believe that many American viewers will agree. And here is the other hand drill after removing the rust and dirt. But there is actually a gear missing and some other important parts as well. And since I still have a whole assortment of these types of drills, I guess I will simply keep this and reuse the bevel gears at some later point for one of my little inventions maybe. Let's see then if we can get that bell ringing again. I'm not sure whether it describes make or model, but it's called Indophone. And you probably find it strange that there is no E at the end of the word phone. But that's just how that works in German. Indophone is probably short for industry phone or something. While I don't believe that this has anything to do with telephones. You can use the word phone basically for anything that makes sounds, so I guess this was some kind of alarm bell or part of an alarm system or something in a factory some decades back, and it is rated for 12 volts, which is convenient. It runs on DC and probably also on AC, but I can't quite read what the sticker actually says there. Like many things that were made at that time, it was cast from heavy cast iron with great precision before it was then painted in that typical silver greenish look. An old cut-off wire is still in there, and unfortunately the looks of this nice piece of engineering were kind of ruined by white wall paint on probably all of its parts. The trick here is to put these parts in hot water. An ultrasonic cleaner will also heat up the water, but you don't necessarily even need the ultrasonic cleaning. The trick is to heat up the water to a point where the wall paint gets soft, yet the original paint still stays stable. Before you can submerge this in water though, all electric components should be removed. This is a cylindrical electromagnet, also called a solenoid, but it also has a spring and push button contact on its back that is interrupted after the metal bolt inside has rung the bell. This contraption is called Wagnerscher Hammer here in Germany after its inventor. That simply means Wagner's or Wagner's hammer. The combination of electromagnet, bell, spring and switch allows this mechanism to generate this periodic back and forth action even with DC. The red capacitor here looks bulgy and needs to be replaced. While I'll leave the metal parts in the ultrasonic cleaner, mostly just to heat them up, I replaced that cap with another very similar model, 3.3 microfarads at 160 volts. After some time, the wall paint has become soft and I gently brush it off with a brass brush. with the wall paint gone and the capacitor replaced, we can put it all back together and maybe test this bell for the first time with a 12-volt battery. In the slow motion footage, you can clearly see how the little hammer interrupts the electrical connection of the solenoid at a fixed frequency. It's always hard to convey via a video how loud or quiet something is that I'm filming here, especially since a lot of the modern recording equipment will automatically level down what is way too loud. And believe me, this bell is so loud that I cannot test it without proper ear protection here in the shop. I think it would be really neat to build an alarm system for the workshop around this bell. One that I could manually activate, but which could also be triggered by sensors, like for example a motion detector. In order to make that possible, I thought it would be really cool to bring this little enclosure and this bell together in that project, since they share the same style and were made around the same time. Inside we find two push buttons that we will take a closer look at soon, as well as this 230 volt signal lamp. Since we're going to build a 12 volt system for that bell, we're not going to use the old lamp. We will instead insert this red 20mm LED inside the old indicator, combining the style of yesteryear with the technology of the present. In order to make some space for a board that I will install here, I shorten this old plastic tube and glue the LED in place. I'm rewiring the old buttons. I cut out a piece of Vero board and I'm adding a MOSFET and a voltage regulator, some screw clamps and a hex Schmidt trigger inverter circuit. Since I don't have a lot of space here, I will connect the components both on the top as well as on the bottom side of the board. Now a comparator, an electrolytic capacitor and some resistors have been added as well. 2 holes are drilled into the walls, since this cast aluminum enclosure will also act as a heatsink for MOSFET and voltage regulator. But as almost always, these packages need to be electrically insulated from the enclosure and each other. After connecting everything properly, we can test if pushing the red button will allow me to manually turn the alarm on and off. Since that worked just fine, I will now try to connect this passive infrared motion detector to the Arduino board that now controls the alarm bell. And it worked just fine as well. So what have I actually built here? And what is it good for? Well, say you have found a cool looking old switch panel, like I did on the last episode, and you want to reuse the push buttons on there in conjunction with the microcontroller, like the Arduino Uno. If you try that, you will inevitably run into bouncing issues. What does that mean? Well, pushing a mechanical push button does quite counterintuitively not deliver just 2 clearly defined logical states with sharp rising and falling edges. Instead, what you get is a jittery signal that the microcontroller will often misinterpret. The microcontroller is so fast that it might interpret one push of a button as several on and off states in a row. In the last episode, this was solved in software using software debouncing methods. This time, I solved it in hardware. So let's take a closer look then at the situation we encountered there. Some of the basic components we saw here are our alarm bell, push buttons, here I have drawn just one for the moment, an LED, a MOSFET, and on that same board a linear voltage regulator. And in addition, we want to connect an Arduino Uno microcontroller board. And we start by taking a closer look at one of the buttons again. While being idle, 2 of the contacts are connected, here on the right hand side, while the 2 others are disconnected. Then while pushing the button down, there is an intermediate state in which none of the pins of the button have any contact. And when pushed down entirely, There is no connection on the right hand, but a clear connection on the left hand side. In the next step, I used some wires to connect these parts together, and I also attached wires so that plus 5 volts and ground were also connected to 2 of the contacts. This will allow to have an output pin that will either be connected to plus 5 volts, meaning logical high, or ground, meaning logical low. In order to pull that state up to high throughout that intermediate state, I later added a 10 kilo ohms resistor that ensures that the output will be logical high until the button is pushed all the way down. But why did I connect the button in such a way that it has the state of plus 5 volts when idle? Meaning, why would it be on when not pressed? Well, here comes our Schmidt trigger into play. The Schmidt trigger is supposed to debounce the switch on the hardware side and ensure a clearly defined switching pulse when the button is pushed. Since this particular Schmidt trigger is also inverting the signal, pushing down the button all the way will give us plus 5 volts again at the output of the Schmidt trigger. And since we have 2 buttons in that enclosure, all this is implemented on the board not once, but twice. But this is only enough to have an input signal for the Arduino. We also need some additional electronics to actually have the alarm bell ring. The bell is rated at 25 watts at 12 volts DC, which would result in a current of a little over 2 amps on average, while the I/O pins of the Arduino can only deliver a few milliamps at 5 volts DC. Therefore, the MOSFET was introduced to switch the bell instead. The big red LED cluster was connected in parallel to the bell. It also has a 220 ohms current limiting resistor. You often see 470 ohms resistors in use when LEDs are powered from a 12 volt rail. In this case, however, the red 20mm package actually contains several LEDs in one package, and that is why I chose a smaller value here. A protection diode was also added to the alarm bell. The MOSFET I used in this project was salvaged from some piece of scrap PCB, and it's not a logic level MOSFET, meaning that it was not built to be switched with a voltage as low as 5 volts. Therefore, we need some kind of driver or level shifter circuit. In order to do that, I connected a comparator to the gate of the MOSFET. This will allow us to use the 12 volt rail to activate it. But since the comparator has an open collector output, this resistor connecting to the 12 volt rail is necessary. Standing alone, it would act as a pull-up resistor for the gate, but the comparator will pull the gate down if forced to do so. And in order to ensure that, the inverting input of the comparator is connected to a voltage divider that will provide it with around 3.8 volt, and the non-inverting input has a pull-down resistor and will only be pulled up if there is a positive input signal from the Arduino. But there is still a little thing missing in order to generate a 5 volt rail for the logic level circuitry and the Arduino. A 7805 voltage regulator was thus added to the circuit. Sensors, like the passive infrared motion detector, can now be tied to the Arduino, and the alarm bell can be triggered that way optionally. Let's take a quick look at that pipe cutter then. A quality pipe cutter of this size would still cost you around 70 to 120 euros if bought new today. Unfortunately, this one has a broken cutting wheel, but I hope that I can just buy a replacement. The jaw of the cutter is also moving only with a lot of resistance, and so do the little steel rollers here. I take it all apart and once again let the ultrasonic cleaner do its work. After also putting it into the citric acid and oiling it, the screw is turning easily again and the jaw moves without any effort. And fortunately, I was able to buy a replacement wheel from another manufacturer for around 10 euros. And after having installed the wheel, which is simply held by a pin, I try to cut an aluminium tube. Okay, so it works with soft aluminum. But what about stainless steel? And I don't know if you still remember, but before we found all those other tools, I had actually gotten my hand on that plate shear, and we still have to take care of that as well. I decided to repair it apart from the other tools because it was the only one big enough to justify using the wire wheel. After taking it apart, I do just that, wire wheeling. And after I had thought that it was a good idea to use the smaller angle grinder for this job just 2 months ago, I learned rather painfully that there are advantages to the large angle grinder here. After I had removed all that paint from that drill press I repaired back then, I noticed a pain in one of my finger joints that still hasn't entirely vanished to this day. I suspect that the excessive vibrations caused by the smaller angle grinder and rather out of center wire brush caused that. The big angle grinder might be heavy, but it is much more stable and smooth, especially with a quality wire brush that is not that out of center. It vibrates much less. That's why I have brought it back from temporary retirement. And after wire wheeling the shear, it got the usual treatment with the citric acid in the ultrasonic cleaner. It was eventually dried, reassembled and oiled. This leaves us with only one little item left to take care of, the old PlayStation. Someone obviously spray painted this, and one thing is for sure, that paint is incredibly hard to get off. As you can see here in this 3D model, the paint was only applied to the top part of the enclosure though. Therefore, I'm now removing that top part in order to clean it. With the electronics exposed, I use that opportunity to remove dust from the inside. I do that with compressed air from a can. The optical drives in CD and DVD players and the like often stop working because of dust. One way to get rid of that is compressed air. I've done this successfully with a compressor before, but some people have suggested that the air from the compressor might indeed be too oily. Again, I put the parts into the ultrasonic cleaner. I had it run for almost the entire day, but the result was less than satisfying. I had to revert to my old method of WD-40 and steel wool, and a whole lot of scrubbing had to be done. And well, after that I cleaned it, I put it back into detergent, then dried it again, and eventually So guys, as always, I hope that you enjoyed this episode, and if that is the case, please give the video a like to let me know that you want to see more of this type of content, so that I can go full steam ahead with the production of new episodes. If you want to support this undertaking more actively, you can visit my Patreon page under patreon.com/tpai or make a donation via PayPal. Links down in the video description. See you soon, guys.